Alright, so today we're going to look at volume of a sphere. And a sphere is in the shape of a ball. And a sphere has a center. And to find the volume, it's going to be volume equals 4/3 pi r cubed. All right, and when you're talking about volume, remember it's going to be units cubed because it's three-dimensional. And this is your radius. And you got to take note of that because sometimes you'll be given the diameter. So just make sure you don't confuse the two. So let's look at example 1 on how we actually use this formula. So example 1 says to find the volume of the sphere. So it's giving us a sphere that's got a radius of 4 centimeters. So we're going to use a formula. Volume equals 4/3 pi r cubed. All right, so volume we don't know, 4/3, and we can go ahead and plug in 3.14. And this time r, which we do have, is 4. So I'll go ahead and put 4 to the 3rd power. All right, and multiplying all that together, 4 times 4 times 4, 4 cubed, is 64. And then I have, well, we'll just do this again. And I'm hoping you're using a calculator to figure all this stuff out. And we'll have volume equals, on the calculator, punch all that in, and you get 268 centimeters cubed. Right. Now, I have to give you some kind of quick knowledge on something that I don't think you learned yet, but it came up, so we have a list of inverses already that we've learned. When we have addition and you want to reverse the operation, or the inverse operation is to subtract. When you have multiplication, the inverse was to divide. And then there's a new set of inverses. So if I have x to the 3rd power and I want to get rid of that 3, I'm trying to solve for x. What would be the inverse operation? And that inverse operation is taking the cube root of something. And taking the cube root, if you have this, and you want to get that x all by itself, you put it to the 3rd power, because that's its inverse operation, and then x will come out all by itself. So if, for example, if I have 2 to the 3rd power, that's 8. And if I have the cube root of 8, that's 2. So that's how cube roots work. What number to the 3rd power gave me 8? 2. 2 to the 3rd power is 8. So just keep that in mind because we're going to need that in the next example. Not these specific numbers, but that concept. And find the radius of the sphere. All right, and here's your sphere. We don't know what the radius is, okay, but we do know the volume. And the volume is given to us as 288 pi. So we're going to use our formula that we already know. And we're going to plug in the things we know. We know that volume is 288 pi. We have 4/3. We do know what pi is, but I'm just going to leave it for now as pi. But we don't know the radius. All right? And so I want to get rid of this, but I have to multiply these together. I'm going to put a 1 under my pi. When I multiply straight across, I can write this as 4 pi all over 3. And I still have r cubed and 288. Now, if you can recall, what can I do to get rid of a fraction? There's a rule that we've done before that helps me eliminate the fraction instantly and wipe it out. And that is to use the reciprocal. So what I'm going to do is I'm going to multiply this by 3 over 4 pi. I do to one side, I do to the other. Okay, so let me zoom that in. So now to do this, let me get another paper. Now what I'm getting here is this would be 12 pi over 12 pi, which is gone. And then we end up with just r cubed. And then on this side, you put a 1 under here, and you get 864 pi all over 4 pi. And then now I'm going to cancel these out, pi over pi, and that leaves me with 216 equals r cubed. So now we have to ask ourselves, what number to the third power is 216? If you know it, great, then just write it down. This number equals r. But if you don't, then that's when I was asking you earlier about the, or telling you earlier about the inverses. So you're going to have to take the cube root, because these are inverses, r will be all alone. Now you take the cube root. So what is the cube root of 216? And that answer was 6. 6 to the third power is r. How did you know? If you didn't know, then you just have to punch it in a calculator, or just ask yourself, is 2 times 2 times 2 3? Is 4 times 4 times 4? What's 5 times 5 times 5? Until you find the one that reaches 216, and that was 6. All right? So for example 3, it discusses a hemisphere. And if you've never heard of a hemisphere, or if you have and not sure what it is, it's just the half of a sphere. So half of a sphere. And you would literally just have to take the entire sphere, volume, and then you would just divide it by 2 and take half of it. So here's the figure they're asking for in example 3. He wants to find the volume of it. And it looks like this. So we got this dome. And it's on a cylinder. And that cylinder has a radius of 12 feet. And the entire figure has a height of 52 feet. And they're asking us for the volume. So you can see that it's actually 2 figures in one. You have a hemisphere, and then you have a cylinder. So we're going to split this up into 2 different figures. So first, let's focus on this hemisphere. Which has a diameter of what? If this is a cylinder, then this base and this top are the same. So if the bottom is 12, radius of 12, then so is the top, 12 feet. So that would be volume equals, well, and let's assume it's the entire sphere. The entire sphere would be 4/3 pi r cubed. But since it's I only want half of it, I'm going to go ahead and put a half in front. I want half of the entire sphere. And now I'm going to go ahead and look at the cylinder. Oops. And that cylinder has a radius of also 12 feet. And the height, we got to figure this out. So what's the height going to be? The height of the entire thing is 52. But now I need to find just the height of the cylinder. Now, on a sphere, the distance from the center to one point is the same in all regions. So with that said, that means this radius is the same on every single point on the sphere. Okay, all of these radiuses are the same. So I'm going to focus on the radius that goes from the center straight up. That's also 12. So that means I have actually a distance of 12 from here to here, because that's still the same radius, 12, 12. And that underneath that would have had to have been 40, because this would be 12 and 40 makes that entire 52. So instead of the radius going to the right, I can also make the radius go straight up and make that 12. So therefore, I'm going to conclude that the height over here is 40. Right? And so now, the volume of a cylinder, we know, is base times height. The base is a circle, pi r squared, times the height. So then we know the values are pi times 6, and that is a radius. You can use 12 times 40. Volume equals pi times 144 times 40. And I'm going to put these two together. I'm going to get 5760 pi. And it's out of order. But over here we would have had 4 over 6 times pi times r cubed. So volume equals 4 over 6 pi times, or 12 to the third power is 1728. And these two gives us 1152 pi. I like to just leave pi because it's a decimal and I can just substitute it with the symbol. And so the final volume is going to be this figure is going to be these two together. So it's 1152 pi plus 5760 pi. So altogether it comes out to be 22,000 approximately feet. Notice I like to keep pi to the very end because I don't want to, if I keep approximating, it becomes less accurate. So the one time that I punch in 3.14, I'm sorry, the least times I punch in 3.14, the better. So just carry on pi to the very end. Calculate it to get a more precise answer, and that's cubed. So there you go. That's the entire volume of that figure.